Ancient asteroid impacts played a role in the creation of Earth's future continents. And here is a satellite image of NASA. You can see a lot of these things if you have time to look for them yourselves, especially in Canada. You have an impact also in the Gulf of Mexico. You have a lot of them in Australia. They're all over the planet. You can imagine what a catastrophe these things would have created. And it's said that the heated magma of the Earth is hot because of the fact that they were struck by asteroids around the area. But anyway, they also played a role in creating the Earth's future continents. This is a recent article, January 31st, 2019. It's on Science Daily. The source is University of Witwatersrand. They say the heavy bombardment of terrestrial planets by asteroids from space has contributed to the formation of the early evolved crust on Earth that later gave rise to continents, home to our human civilization. And you have a model for the compositional evolution of early Earth's crust due to fractional crystallization of impact melt sheets, followed by detachment and by sinking of their dense primitive portions towards the crust mantle boundary. The asteroid would hit, the Earth would there would be subduction because of the weight of the asteroid and the force of the impact, and that's how you would get the differentiated impact melt sheet. So that's how the geology was active in that way. The model for the compositional evolution of Earth's early crust due to fractional crystallization of impact melt sheets, followed by detachment and sinking of their dense primitive portion towards the Earth's crust mantle. The heavy bombardment of terrestrial planets by asteroids from space contributed to formation of early evolved crust on Earth. More than 3.8 billion years ago, in a time period called the Hadean Eon, our planet Earth was constantly bombarded by asteroids, and this caused a large-scale melting of its surface rocks. They even melted. Most of these surface rocks were basalts, and the asteroid impacts produced large pools of superheated impact melt of such composition. These basaltic pools were tens of kilometers thick and thousands of kilometers in diameter. Quote, if you want to get an idea of what the surface of Earth looked like at the time, you can just look at the surface of the Moon, which is covered by a vast amount of large impact craters, end quote, says Professor Rais Latipov from the School of Geosciences, the University of the Witwatersrand in South Africa. The subsequent fate of these ancient giant melt sheets remain, however, highly debatable. It has been argued that on cooling, they may have crystallized back into magmatic bodies of the same broadly basaltic composition. In this scenario, asteroid impacts are supposed to play no role in the formation of Earth's early evolved crust. An alternative model suggests that these sheets may undergo large-scale chemical change to produce layered magmatic intrusions such as the Bushveld complex in South Africa. In this scenario, asteroid impacts may have played an important role in producing various igneous rocks in the early Earth's crust and therefore may have contributed to its chemical evolution. Now, there's no direct way to rigorously test these two competing scenarios because the ancient Hadean impact melts have been later obliterated by plate tectonics, but by studying the younger impact melt sheet of the Sudbury Igneous Complex, SIC, in Canada, Latipov and his research team have inferred that ancient asteroid impacts were capable of producing various rock types from the earlier Earth's basaltic crust. Most importantly, these impacts may have made the crust compositionally more evolved, hence silica-rich in composition. Their research has been published in the paper Nature Communications. The SIC, that's the Sudbury Igneous Complex, is the largest, best exposed and accessible asteroid impact melt sheet on Earth, which has resulted from a large asteroid impact 1.85 billion years ago. This impact produced a superheated melt sheet of up to 5 kilometers thick, and the SIC, the Sudbury Igneous Complex, now shows a remarkable magmatic stratigraphy with various layers of igneous rocks. Quote, our field and geochemical observations, especially the discovery of large discrete bodies of melanorites throughout the entire stratigraphy of the SIC, allowed us to reassess current models for the formation of the SIC and firmly conclude that its conspicuous magmatic stratigraphy is a result of large-scale fractional crystallization. This is what Latipov explains. He adds, quote, an important implication is that more ancient and primitive Hadean impact melt sheets on the early Earth and other terrestrial planets would also have undergone near-surface large volume differentiation to produce compositionally stratified bodies. The detachment of dense primitive layers from these bodies and their sinking into the mantle would leave behind substantial volumes of evolved rocks, buoyant crustal blocks in the Hadean crust. This would make the crust compositionally layered and increasingly more evolved from its base towards the Earth's surface. These impacts made the crust compositionally more evolved, in other words, silica-rich in composition, says Latipov. And he says, traditionally, researchers believe that such silica-rich evolved rocks, which are essentially building buoyant blocks of our continents, can only be generated deep in the Earth, but we now argue that such blocks can be produced at new surface conditions within impact melt pools, end quote. This is from the University of the Witwatersrand in South Africa. Journal reference, Rais Latipov. And it's on Nature Communication. This is on Science Daily. I'll leave a link below for you for this. Thank you. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.